Hey guys, welcome to Chapter 5.1 Practice Problem. So, we just finished Chapter 5.1. It was a little long. I gave you a few examples, but now we're going to do a full problem out of the book. So, we're going to be doing page 254, number 64. So, here's the problem. It gives you f of x is ax plus b over cx plus d, and g of x equals mx. Part A is to find f of g, part B is to find g of f, and C is to find the domains for both of them. So let's start with A. So A is asking for f of g of x. That's what the f of g symbol meant. So we can solve this like the way we're solving all other composite functions. So replace the inside with the actual function of g of x, which is mx. So rewrite it f of mx. And so if you remember, the function f of x equals ax plus b over cx plus d. So everywhere we've seen x, we're going to plug in the inside, which is mx. So a mx plus b over c mx plus d. And so that's it for A. Part B is g of f of x. So we're going to do the same thing except reverse order. So g of, and then rewrite f of x, ax plus b over cx plus d. G of x is mx, so everywhere we see an x, we're going to plug in this inside. So m ax plus b over cx plus d. So now we can distribute the m in if you want. max plus mb over cx plus d. So now we're going to want to find the domains. So first, we'll start with f of g of x. And so the domain of this, if you remember, we broke it down in the last video into 3 steps. The first step is to find the domain of the inner function, which is g of x. Let me rewrite these up here. G of x equals mx. F of x equals ax plus b over cx plus d. So the domain of the inner function, mx, is just going to be all real numbers. So our second step is the domain of the outer function, which is f of x. We can see that's here is going to be, the denominator cannot equal 0. So 6x plus d cannot equal 0. Cx cannot equal negative d. Divide c by both sides. X cannot equal negative d over c. So now the third step is to set the inner function equal to the domain of the outer function. So the inner function is mx. Set it equal to negative d over c. So x, this can be cannot equal. So x cannot equals, I divide m by both sides. So x cannot equal negative d over cm. And then step 4 was to combine steps 1 and 3. Since this is all real numbers, this doesn't matter, so we can just say the domain is x such that x does not equal, move this over a second, does not equal negative d over cm. Now we can find the domain of the second one, which is g of f. And so we're going to do the same steps. So step 1, inner function, which we just did. We said cx plus d cannot equal 0. Cx cannot equal negative d. X cannot equal negative d over c. Step 2, domain of the outer function, all real numbers. We already said that. 3, set the inner function, which is f of x, equal to the domain of the outer function. In this case, the outer function is all real numbers, so it doesn't really matter. What you would end up doing is ax plus b over cx plus d equals all real numbers. And you're not going to be solving anything here because there's no number over here. It can be any number. So we're just going to go right to step 4, which is combine parts 1 and 3. 3 doesn't matter here, so we're just going to do 1. So basically the domain is x such that x cannot equal negative d over c. That's your answer. So that's it for composite functions. It's pretty straightforward. Just remember your orders when you're finding the domain, because the domain can get a little tricky. But yeah, that's it. So we'll see you in the next video. We'll be going over 5.2. We'll be dealing with inverse functions. Thanks for watching.